Hello, students. So, to move ahead, we should understand what exactly a network is. A network is a set of devices, often referred to as nodes, connected by communication links. A node can be a computer, a printer, or any other device capable of sending or receiving data generated by other nodes on the network. Next terminology is distributed processing. Most networks use distributed processing in which a task is divided among multiple computers. So instead of one single large machine being responsible for all aspects of a process, separate computers, usually a personal computer or workstation, handles a subset. Network criteria. Network must be able to meet a certain number of criteria. The most important of these are performance, reliability, and security. So, let us start one by one to understand what the different criterias are. To begin with, the very first, performance. Performance can be measured in many ways, including the transit time and the response time. Now, you must be thinking that what exactly is the transit time? Transit time is the amount of time required for a message to travel from one device to another. Response time is the elapsed time between an inquiry and a response. The performance of a network depends on a number of factors, including the number of users, the type of transmission medium, the capabilities of the connected hardware, and the efficiency of the software. Performance is often evaluated by two networking metrics, throughput and delay. We often need more throughput and less delay. However, these two criteria are often contradictory. So, if we try to send more data to the network, we may increase the throughput, but we increase the delay because of traffic congestion in the network. The next term for network criteria is the reliability. So, in addition to accuracy of delivery, the network reliability is measured by the frequency of failure, the time it takes a link to recover from a failure, and the network's robustness in a catastrophe. The last criteria is the security. Network security issues include protecting the data from unauthorized access, protecting the data from damage and development, and implementing policies and procedures for recovery from breaches and data losses. Now, till here, the very basics or the foundations which are required to start with the understanding of OSI model layers would be clear. Just one more thing, that how devices connect to each other, whether they are connected point to point or multi-point. So this topic comes under the head of types of connections or physical structures. So before discussing the networks into more detail, we need to define some network attributes. Types of connections. A network is two or more devices connected through links. A link is a communication path that transfers the data from one device to another. For visualization purposes, it is simplest to imagine any link as a line drawn between 2 points. For communication to occur, two devices must be connected in some way to the same link at the same time. There are two possible types of connections, point to point and multi point. Point to point, a point to point connection provides a dedicated link between two devices. The entire capacity of the link is reserved for transmission between those two devices. Most point to point connections use an actual length of wire or cable to connect the two ends, but other options such as microwave or satellite links are also possible. When you change the television channel, now just for example, we are taking a real life example. So when you change the television channels by infrared remote control, you are establishing a point to point connection between the remote control and the television's control system. Next term, we all should be able to differentiate between point to point connection and a multi point connection. A multi-point, also called as a multi-drop connection, is one in which more than two specific devices share a single link. In a multi-point environment, the capacity of the channel is shared either spatially or temporarily. If several devices can use the link simultaneously, it is a spatially shared connection. If users must take turns, it is a time shared connection. So, here we end up the foundations which are required to study the OSI model. OSI stands for Open Systems Interconnection Model, which comprises of 7 layers, each serving a distinct role in network communication. So as you can see on the screen that the 7 layers are: very first, the physical layer, data link layer, network layer, transport layer, session layer, presentation, and application in a sequence from bottom to upwards. Physical layer, which deals with the transmission of raw bit streams over a physical medium. In a very brief, I am telling you at this stage. In coming next lesson, we will go into more detail. So data link, responsible for node to node data transfer and error detection. Network layer, which manages the routing and forwarding of packets. Transport layer, ensuring the reliable communication, and so on. Now, in contrast, the TCP/IP model condenses into 4 layers. Here we were having 7 layers, and there you have 4 layers: link layer, internet layer, transport, and application, where the link layer encompasses both the physical and data link layers of the OSI model. Understanding these layers is very crucial for troubleshooting and designing of the networks, as each layer interacts with the others to facilitate the seamless communication. Network devices per layer. Now we have understood the basic functioning of the each layer, but to perform these functions at every layer, there are various network devices. So, in coming lecture, we would be understanding about